Okay, here's how you do a ray diagram for a converging lens. First, go to the middle of the lens and kind of make a dotted line if one doesn't already exist for you. When I was younger and I tried to do ray diagrams, I would go to like the surface of it and then I'd try and do like Snell's law in my head, and it was super complicated. Just make a line there. Okay. Now we have our little robot friend. He's back and he doesn't just hate mirrors, he hates lenses. I didn't draw this very well. It's clearly not to scale because he's going to be barely hitting this laser, but whatever. You're going to go flat to focal, okay? Now, unlike a mirror, which bounces light back, a lens refracts light, so light is going to keep moving forward. So we're going to go like this. Oh, we're going to go flat to the middle to focal, and you're going to go to the focal point on the other side. Okay, you're going to go to the focal point on the other side because, again, light refracts, not reflects. So in other words, if the robot were to shine a laser perfectly flat toward this, the light would then it would converge down toward the focal point. There's lots of other ways to do ray diagrams for converging lenses. I actually find this to be the easiest one. If you just happen to shine a laser right toward this middle point, basically you're kind of be going straight through. So we say flat to focal, and if you were to shine laser light directly through the middle here, it would actually go straight through. So what you do, flat to focal through the center. So I'm going to connect, I'm going to lay down my ruler connecting between here and here, so the top of the robot head in there. And then I'm going to just draw that line through and keep going till it hits the other guy. Okay, that means that my image will appear over here. Didn't draw that very well. And you can see they're connecting here. So this would be the top of the robot's head. It's a little laser light here. And so it's going to be inverted. Oh gosh, something happened to its arms along the way. It's going to be inverted. It's going to be bigger. And I also want you to notice that this is actually going to be a real image. Now you feel like, that's the exact opposite of the mirrors. But remember, it's because the observer is over here. So the observer would have to hold up a screen here in order to see that image. The real would be on the same side. If it was a virtual image, it would be like the person would have to look through the lens to see it. And that is just not the case. All right, that's one down. I'm going to show you some other examples. Before moving on, make sure that you can do this. So draw this scenario down on your paper, and without looking at what we just did, see if you can find where the image would be. I'll just wait for you to do that. Actually, you could just pause the video and we'll just wait for that to happen. In the last situation, we had the object standing outside of the focal point out here. Now we're going to move it in, and it gets a little bit more complicated, but not too bad. So here's our little robot, and we're going to have our robot's little head laser, and it's going to shoot at the lens. So we're going to draw our little line down the middle, and we're just going to really bend at that point to make things a little easier. So shoots flat. So again, we do the same rule can apply. Flat to focal. So you go, oops, I blew up the letter. Flat to focal. Okay. Anytime you're inside the focal line, it's going to be a little bit more complicated. So I'm just going to say, as a general rule, if you are inside the focal line, both for mirrors and lenses, always a good idea to continue back and show where it looks like the light came from. So what am I drawing there? I kind of explained that with mirrors, but let's talk about this. If the observer is over here, which we've discussed, to them, I mean, that person doesn't know that laser light bends. So to them, if they're looking at this laser light coming into their eyes, it looks like the laser was shot straight at them, so it came from somewhere up here. Okay, so people call these back rays or virtual rays, doesn't matter. Just use a dotted line when you're drawing them do not show them as a solid line. The solid line represents the path the light actually took. The dotted line represents where people think that light came from. All right, so we did focal, flat to focal, and now we're going to do through the center. So we're going to go from the top to the very center of our lens. Oh gosh, this is not going to go well here. I'm using a notepad because I don't have a ruler at my house. I'm a terrible person. Okay, so now I'm going to connect. I'm going to lay down my ruler, and this is the path the light would actually take. But to the observer, it will look as though the light came from back here. So you're going to continue it back. And you'll notice that on the real side of the lens, these light rays do not cross. So it doesn't look like anything was made. There was no real image. There's no virtual image. But behind the lens, on the virtual side, it looks as though these rays came from one spot over here. In other words, that's where the light rays crossed. So what can we do? We can draw our image. Okay. Oh, I didn't draw that very well. So here's our robot. Again, none of this is to scale because I'm using my iPad. It's pretty tricky to do on here. But you should have a virtual, larger, and upright image from your ray diagram. What if, weird question here, I put the object exactly on the focal point? What would happen? What does your gut tell you would happen? Okay, let's find out. All of these work as long as you keep following the same rule, which is flat to focal. And we're gonna just go from the middle here and connect down. Oh, that went rough. It's okay, should be fine. And then through the center. So through the center would look like, boop. And if you see, these lines, I mean, I didn't draw them perfectly. They're pretty much not going to cross. They're basically parallel. So you will not get an image. If you ever take one of these and you put an object actually at the focal point, you'll see that you don't really get an image. You don't get a real one on one side. And if you look through, you don't really get a virtual image either. It looks kind of like a weird, darkish, warped spot. I'm really not explaining it well. You should try it out as soon as I get back and I can hand you the lenses. That'd be great. Okay, I'm going to do other lenses now.